Example 3 is asking us to use the graph of f prime shown to sketch a graph of f prime prime and a possible graph of f. To begin, we are going to fill out our f prime number line based on where the f prime graph is positive and where it is negative. The y values of f prime are below the x-axis from negative infinity to negative 2. The y values of f prime are positive above the x-axis from negative 2 to positive infinity. So our critical number, where f prime changes from negative to positive or positive to negative, is at x equals negative 2. And to the left of negative 2, our interval is negative, f prime is negative, so this interval here will be negative, which means f is decreasing from negative infinity up to negative 2. And from negative 2 to infinity, f prime is positive. So from negative 2 to infinity on the f prime number line, we have a positive interval, which means that f will be increasing from negative 2 to infinity. To complete the f double prime number line, there are some important pieces of information. When f prime changes from increasing to decreasing or decreasing to increasing, f has a point of inflection. So those numbers would need to be noted on the f prime prime number line. The other values for which we would need to note on the f double prime number line are x values for which the slope of a tangent of f prime is 0. Okay, so where you have a horizontal tangent or where the graph of f prime is undefined. And visually, when f prime, the graph of f prime is undefined, that is where f prime is not differentiable. Remember the conditions for differentiability? It can't be a hole, a sharp turn, a jump, an asymptote, or a vertical tangent. First, I will look for any times that there is a horizontal tangent for f prime. There's not a horizontal tangent here, but there's no tangent there. It is f prime is not differentiable at x equals 0. So 0 must be noted on the f double prime number line. Now I will look at where the graph of f prime is increasing or decreasing to see if 0 is a point of inflection or not. From left to right, f prime is steadily increasing. We are not decreasing at any time in the graph of f prime. So the interval for the f double prime number line less than 0 is positive because f prime is increasing. And the interval to the right of 0 is also positive because the graph of f prime continues to increase. This means that f will be concave up. Because the graph of f will be concave up, 0 is not a point of inflection. To graph f, I will look for any relative extrema. And relative extrema are given to me from the f prime number line, where we see the intervals of increasing and decreasing. So f is decreasing from negative infinity to negative 2 and is increasing from negative 2 to infinity. Therefore, we have a relative minimum at negative 2. When you change from decreasing to increasing, you have a relative minimum. When you change from increasing to decreasing, you have a relative maximum. I will graph the relative minimum, x equals negative 2, but they didn't give me a starting point, so I don't know how high up that is. I don't know if the relative minimum is negative 2, 4, or if the relative minimum is negative 2, negative 3. I don't know the vertical shift of f given the graph of f prime. So I'm just going to pick a value that I think will help show the entire graph of f as much as possible. So I'm going to pick negative 2, negative 2. You could have picked negative 1, 0. -3. Honestly, I just want it to fit on this coordinate plane nicely. Knowing x equals -2 is a relative minimum will help me know the behavior on either side of -2. And I'm going to guess kind of the stretch or how far it goes up based on the slopes of f that are given to me by the f prime graph. So the slope at -3 is -1, right? The y value on the f prime graph is the slope of the f graph at the x value given. So the slope at -3 is -1. I want the slope here to be -1. Is that a slope of -1? This looks like it might be a slope of -1, so I'm going to go up a little bit. The slope at -1 is +1, so I know it is symmetrical. The slope at -4 is -2, so I know it's growing even more. Will that give me a slope of -2? Maybe a little bit lower. Will that give me a slope of -2? Somewhere in there. Yeah, it looks about right. Remember, we're just sketching. And at 0, I have a slope of 2. So symmetrical again. I'll just make those x-intercepts so it just kind of looks prettier. The slope at, let's say, 1/3 is almost 0. So this is barely growing. The slope at 1 is 3. So then we're growing a lot more. I think that would be a pretty good estimate. Okay, f prime is decreasing from -infinity to -2, and it's concave up. Decreasing and concave up. From -2 to infinity, f is increasing because the f prime number line is positive on that interval. Now f prime prime tells us that the entire graph is concave up, so this will continue to be concave up. We will connect our last few points to continue an increasing graph of f. Now, if that seemed a little bit difficult, there was a kind of a way that I visualized it that made it a little bit simpler for me. I noticed that the graph of f prime is basically made up of two pieces. To the left of the y-axis, we have a line. And to the right of the y-axis, we have, looks like a half of a parabola. So I thought to myself, a line is the derivative of what polynomial? Line is the derivative of a parabola. So if to the left of the x-axis the graph of f prime is a line, then to the left of the x-axis the graph of f will be the antiderivative of a line, which is a parabola, because the derivative of a parabola is a line. And then to the right of the y-axis we have a parabola, and we know that a parabola is the derivative of a cubic function. So to the right of the y-axis in the f graph, we will have a cubic function, part of a cubic function. And that is a really helpful way to know how this will curve and to also check. To sketch a graph of f prime prime, we look at the slopes of f prime. So I always think of it in my head, I just imagine this is the f graph and I'm sketching the f prime graph because we have had a little bit of practice doing that. So I am going to start at any place where the slope of the f prime graph is 0 or undefined? Oh, okay, we already found that it's not 0 anywhere, but it is undefined because f prime is not differentiable at x equals 0. So if f prime is not differentiable at x equals 0, then f prime prime will not exist at x equals 0, since f prime prime represents the differentiation of f prime. Since I previously noticed that the left half of f prime is a line and the right half is a parabola, the derivative of f prime, the derivative of a line, is a constant, and the derivative of a parabola is a line. So to the left of the y-axis on f prime prime, I will have a constant, meaning a horizontal line, and to the right, I will have part of a parabola. And at x equals 0, f prime prime will have a hole. The slope at -1, because I don't know where the hole is for x equals 0, so I'm going to try the slopes around and hope that helps me. The slope at -1 is +1. So at -1, I will put a point at +1. The slope at -2 is also +1. In fact, the slope from -infinity up to 0 basically is +1. So this will be a horizontal line at +1 approaching x equals 0, but not including x equals 0. So now I have a better idea of where my hole will be. Then on the right side of f prime, we have sort of a parabola. The slope at about 1/2 is about 1/2. In fact, I'm going to look even closer to x equals 0 at about 1/4. My slope seems to be 1/3 at 0.5. My slope seems to be, I don't know, that looks like it might be 1. And then at 1, the slope looks like it is approximately 2. So do I just have a hole, or do I actually have a jump? Let's look even closer to 0. Let's look at 1/10. The tangent line at 1/10 is getting pretty close to being horizontal. So as you get closer to the y-axis from the right, you are actually approaching a y value of 0. So f prime prime will have a hole at 0, 0, and we'll connect those points. Now, are we sure that one of these holes is not perhaps filled in? Yes, we are sure, because the graph of f prime is not differentiable at x equals 0. The slope is undefined, so since f prime prime is the slope of f prime prime will be undefined at x equals 0. Let's try this example from the Desmos Activity. The figure above shows the graph of f prime, the derivative of function f, for x between -6 and 8 on the open interval -6 to 8. Of the following, which best describes the graph of f on the same interval? So the options are telling us how many relative minima, relative maxima, and how many points of inflection. So that's what we need to find given the graph of f prime. Oh, and don't forget this tasty morsel. When f prime changes from increasing to decreasing or decreasing to increasing, f has a point of inflection. And here are some more helpful pieces of information. You have a relative minimum when the graph of f prime changes from negative values to positive values, and you have a relative maximum when the graph of f prime changes from positive values to negative values. I will begin by locating the relative extrema of f. The intervals for which f prime is positive are -infinity to -2 and 7 to infinity. The intervals where f prime is negative is just one interval, and that's between -2 and 7. So we have some switcheroos where we change from positive to negative and negative to positive. So here we change from positive to negative at x equals negative 2. When you change from positive to negative, you have a relative max. So this will be a relative max of f. Now here we are changing from negative to positive at x equals 7. When the graph of f prime changes from negative values to positive values, then you have a relative minimum. So we will have a relative minimum on the graph of f at x equals 7. This has helped me narrow down my options to at least A or B. We have one relative max and one relative min. But wait, what about x equals 2? Is that a relative max or min? No, because the values of f prime did not change from negative to positive. They went to 0 and then back to negative. We only have relative extrema when f prime changes sign. Our final step will be to determine how many points of inflection f has given the graph of f prime. Points of inflection happen when f prime changes from increasing to decreasing or decreasing to increasing. So I'm going to color those intervals. The graph of f prime is decreasing, decreasing, decreasing until about here. Then the graph is increasing up until we get to where the tangent of f prime would be 0. Our graph of f prime is now decreasing until about, we'll call that 5.5. And f prime is increasing from 5.5 onward. I believe I've been saying negative infinity, but the interval that we're working with is simply negative 6 to 8. So how many points of inflection do we have? Well, points of inflection are wherever f prime changes from increasing to decreasing. At x equals negative 1, f prime changes from decreasing to increasing. F prime has a relative minimum, meaning f has a point of inflection. At x equals 2, the graph of f prime goes from increasing to decreasing, which indicates another point of inflection for the graph of f. And at x equals 5.5, the graph of f prime goes from decreasing to increasing, which indicates another point of inflection. As you notice, points of inflection can be found whenever you have a horizontal tangent on the graph of f prime, because the derivative of f prime is f double prime. Our points of inflection are at x equals negative 1, x equals 2, and x equals 5.5. That gives me a total of 3 points of inflection. So the correct answer would be A, that the graph of f has one relative minimum, one relative maximum, and 3 points of inflection.